Good morning, good afternoon, good evening. Introduction to Artificial Intelligence. This is Professor Atif Reed Muhammad, University of Cumberland's PhD AI 830 course. So, this lecture is a series of 15 or 16 lectures going to be. And in this current lecture, we'll discuss reasoning, learning, perception, and decision making. In today's lecture, we'll explore the exciting field of artificial intelligence or AI. We will begin by understanding what AI means and the different ways researchers define intelligence. Next, we will discuss the foundations of artificial intelligence and disciplines that contribute to its development. Then, we will review the history of artificial intelligence and see how it evolved from simple ideas to today's powerful systems. We will also examine modern AI applications, their benefits, and their challenges they create. Finally, we'll discuss ethical concerns and summaries that the key lessons that we have discussed from this lecture. So, an example before I begin this lecture is when Netflix recommends a movie or Google Maps suggests a fastest route. AI is working behind the scenes. By the end of today's lecture, you will understand how such systems become possible. So, what is artificial intelligence? That's the question of the century at this very moment, in my opinion. Artificial intelligence refers to computer systems that can perform tasks that normally require human intelligence. These tasks include learning from experience, solving problems, recognizing patterns, understanding language, and making decisions. AI is designed to improve its performance by analyzing data and adapting to new situations. Today, artificial intelligence is used in healthcare, education, finance, transportation, and entertainment. Although AI can perform many impressive tasks, it is still designed by humans and works within the limits of its programming and training data. Think about a smartphone voice assistant like Siri or Google Assistant. When we ask, "What is the weather today?" it understands our speech, processes the question, and provides an answer. This is a practical example of AI in everyday use. So, when we are dealing with the artificial intelligence, we look at the narrative surrounding us or the problem set that we are dealing with. I would strongly suggest you to look at Logical Investigations, Volume 1 by Edmund Husserl, where the author has discussed extensively narrative and how it impacts our thought process as human and why it is significant for an artificial intelligence system or foundational model or foundry models to work with to resolve the issues that are needed to be solved within the given parameters, and the parameters comes through a narrative. So the researchers view AI from four different perspectives. The first is acting humanly, where machines behave like humans. The second is thinking humanly, where systems attempt to imitate human thinking processes. The third is thinking rationally, which focuses on logical and correct reasoning. The fourth is acting rationally, where systems choose actions that maximize success in achieving goals. Today, acting rationally is the most widely accepted approach because it focuses on results rather than copying human behavior exactly. A newer perspective also emphasizes building AI that is beneficial, safe, and aligned with human values. A chess playing artificial intelligence does not think exactly like a human grandmaster. Instead, it evaluates many possible moves and selects the one most likely to win. This represents the acting rationally approach. fifth growing view is beneficial machines, systems that are safe, ethical, and aligned with human values. The classic 2 by 2 framework helps us understand the four main approaches to artificial intelligence. On one axis, we have thinking versus acting. On the other, we have human like versus rational behavior. This creates four categories: thinking humanly, thinking rationally, acting humanly, and acting rationally. Each category represents a different goal for AI research. While earlier research focused on making machines behave like humans, modern AI primarily focuses on rational agents that achieve goals effectively even in uncertain environments. A self driving car does not need to drive exactly like a human. Instead, it must drive safely and efficiently. Therefore, it follows the acting rationally approach because achieving the goal is more important than imitating human behavior. Once again, narrative comes into the play. The best recommendation for you to look at the artificial intelligence reading that has been provided to you to look and understand and establish the ideas that how we work with the narrative, how we work with the phenomenology and ethnography, because that allows you to create some reputed ideas to make sure that you are working within the given domain and then you are following the exact what are the philosophy of arithmetic. That's like set membership theory. A union set has every element or every known element of a given universe, and a subset or an intersection set of two subsets is whole different story, but that remains within the given domain for our understanding. All right, modern AI research increasingly focuses on creating beneficial machines. These systems should be safe, ethical, and aligned with human values. Safety means the system should avoid causing harm. Ethics means decisions should be fair and accountable. Alignment means the AI's goals should match what humans truly want. As AI systems become more powerful, mistakes can have larger consequences. Therefore, researchers are asking not only whether AI can perform a task, but whether it should perform that task and under what conditions. Imagine an AI used for hiring employees. If it unfairly favors one group of applicants over another, it may be efficient but not ethical. Beneficial AI seeks to prevent such problems. So it is a common experience that the excellence of an artist's mastery over his material and the divisive certainty with which he or she judges and assesses works in the art is only quite exceptionally based on theoretical knowledge of the rules which prescribe direction and order to the practice, and determine the standards of value on which the perfection or imperfection of the complete work must be assessed. So normally, the practicing artist is not a man or a woman who can inform us rightly regarding the principles of the art. Think about it. This is the emerging standard. We at this very moment are the artists within the given domain of artificial intelligence. So, the foundations of artificial intelligence. AI is interdisciplinary by construction, drawing strength from convergence of 7 distinct fields. So let me reiterate myself. Normally, the practicing artist, as I mentioned earlier, you and me, who's dealing with the art that we are creating using artificial intelligence in any given form, is not a person who can inform us rightly regarding the principles of the art, he or she follows principles neither in his creation nor his evaluation. In the creation, the artist follows the inner activity of his or her harmoniously trained powers. In this individual's judgment, his finely formed artistic taste and feelings. This is not merely so in case of fine art. That is algorithms, that is the foundational models in artificial intelligence, of which one may first have thought, like the BERT, the BARD, the Gemini, the generative pre-trained transformers. But in that of the arts, generally, in the widest sense of the word, it therefore holds for the activities of scientific creation and theoretical evaluation of their results, for the scientific demonstrations of facts, laws, theories that deal with algorithms, data science, computer science, machine learning. Even the mathematicians, the physicist, and the astronomer need not understand the ultimate grounds of their activities in order to carry through even the most important scientific performances. So put yourself in those shoes. As per Dr. Edmund Husserl, I just reiterated from the Logical Investigations, the book he wrote in early 1900. So this is something that I would like to mention, that mathematics is the mother of artificial intelligence. So AI combines knowledge from many disciplines. Philosophy contributes ideas about reasoning and ethics. Mathematics provides statistics, probability, and optimization techniques. Psychology helps us understand learning and cognition. Neurosciences inspire neural networks based on the human brain. Economics contributes decision-making models. Computer engineering provides hardware and software systems. Linguistics helps machines understand language, while control theory supports feedback and stability. Together, these disciplines make AI a powerful and interdisciplinary field. When ChatGPT answers questions, it relies on mathematics for learning, linguistics for language understanding, computer engineering for processing, and psychology-inspired learning models. Reinforcement learning, or RL, is a learning method where an agent learns through trial and error. The agent takes actions, receives rewards or penalties, and adjusts its behavior over time. This idea comes from psychology, where behavior is shaped by reward and control theory, where feedback is used to improve performance. Reinforcement learning is especially useful in environments where the correct action is not known in advance. Consider training a dog. When a dog follows, not allows, a command, it receives a treat. Over time, it learns the desired behavior. Reinforcement learning works in a similar way, except the learner is a computer program. So agents that improve through experience by taking an action, observing a reward, and updating policy, and reinforcement learning agent gradually learns behavior that maximizes long-run returns. A direct fusion of psychological reward learning, as mentioned again, the Sutton and Bartow has mentioned in their publication in 2018 in quite detail. I suggest you to find that paper and give it a shot, read it, it'll help you. A brief history of artificial intelligence: 8 decades of progress, setbacks, and reinvention, from neural models of 1940s through the modern deep learning. The history of AI can be divided into 6 major areas, or specifically in terms of eras that we have witnessed so far. The field began with foundational research in 1940s and 1950s. Researchers then entered a period of optimism and believed human-level AI would arrive quickly. When progress slowed, AI experienced periods known as AI winters. Later, expert systems became popular, followed by statistical machine learning approaches. Today, we are in the deep learning era, where powerful algorithms and large datasets drive major advances. The development of the AI is similar to the growth of the internet. There were periods of excitement, setbacks, and breakthroughs before it became an essential part of everyday life. In the early years, researchers were extremely optimistic about artificial intelligence. They believed machines would soon be able to perform human level reasoning. Funding and interest grew rapidly. However, computers at that time lacked sufficient processing power, and many AI systems could not solve real world problems effectively, and as expectations were not met, funding decreased and enthusiasm faded. This period became known as the first AI winter. Imagine promising that a student can complete a PhD in 1 year. The expectation is unrealistic, and disappointment follows when it is not achieved. Similar overpromising contributed to the artificial intelligence winter. After the AI winter, expert systems became popular. These systems used rules created by human experts to solve specific problems. While effective in narrow domains, they lacked flexibility. Later, neural networks returned with improved training methods such as backpropagation. During 1990s, statistical machine learning became dominant, permitting systems to learn directly from data instead of relying entirely on handcrafted rules. An expert system for medical diagnosis might follow thousands of predefined rules. A machine learning system, however, can learn disease patterns directly from the patient data and improve over time. The deep learning era. So, deep learning emerged because of three key factors: large data sets, powerful computing hardware, and improved algorithms. Deep neural networks can learn complex patterns from massive amounts of data. This has led to significant improvements in image recognition, speech processing, language understanding, and many other applications. Deep learning is one of the main reasons AI has become so successful in recent years. Facebook can automatically recognize the tag faces in photos because deep learning models have learned patterns from millions of images. The state of the art and the risks ahead. Modern AI is breathtaking and brings ethical responsibilities that are larger than the systems themselves. Now let's look into this. Modern AI systems can perform tasks that once seemed impossible. They can recognize objects in images, translate languages, understand speech, generate text, write code, and even defeat world champions in strategic games. These achievements result from combining large datasets, powerful computers, and advanced algorithms. AI is transforming industries and creating new opportunities for innovation. ChatGPT can generate essays, summarize reports, answer questions, and even help programmers write code. This demonstrates the capabilities of modern generative AI. And you can read about mastery of complex games such as Go and chess by Silver et al. 2016 published paper. So while AI offers many benefits, it also presents significant risks. Bias can lead to unfair decisions. Lack of transparency makes it difficult to understand how AI reaches conclusions. Reward hacking occurs when AI finds unintended shortcuts. Misalignment happens when AI goals differ from human goals. Autonomous systems can behave unpredictably, and large scale deployment can create unexpected consequences. Addressing these challenges is essential for responsible AI development. If a bank uses biased training data on an AI loan approval system, may unfairly reject qualified applicants from certain groups, creating serious ethical concerns. So, balancing innovation with responsibility. The future of AI depends on balancing technological progress with responsibility. Building more powerful systems is important, but ensuring fairness, transparency, privacy, and safety is equally important. Organizations must develop AI systems that people can trust. Success in AI should be measured not only by performance but also by positive social impact. A self driving car may have excellent navigation capabilities, but if it cannot safely recognize pedestrians, it should not be deployed. Safety must be considered alongside innovation and is a paramount thing for all of us to work with it. Let's review the main ideas from today's lecture. First, AI can be understood through multiple perspectives, including acting humanly and acting rationally. Second, AI is interdisciplinary and combines ideas from many fields. Third, modern AI is a result of decades of progress and lessons learned from both successes and failures. Finally, safety, ethics, and alignment are just as important as technical performance. These principles will guide our future discussions throughout the course. When evaluating an AI system, we should ask not only does it work, but also is it fair, safe, and beneficial for the people? That's a great question. Further readings and resources. So the links are given here. I would suggest you to look at the links provided in the syllabus as well at University of the Cumberland's PhD AI 830. So learning about AI requires continuous study because the field evolves rapidly and every day that is happening. The videos and the research papers listed here provide valuable insights into AI concepts, intelligent agents, AI safety, and major breakthroughs in deep learning. Exploring these resources will strengthen your understanding of both theoretical and practical aspects of artificial intelligence. The paper Mastering the Game of Go explains how AlphaGo defeated the world champion. It is an excellent example of how advanced AI can solve highly complex problems that were once considered impossible for machines. And this is the end of the lecture 1. From definitions to intelligent agents, lecture 2 turns from defining AI to designing AI, how rational agents perceive, decide, and act inside their environments. So happy learning. See you in the next lecture.